everyone, my name is Kai-Jhong Huang, and what I'm presenting today is a GSM-based field monitoring system for Spototera Natura, and I'm from National Kyoto University. And this is my outline. I'll present like this today. The first, the introduction and material and method, result and discussion and summary and conclusions. Introduction. In fact, that are serious problems to Taiwan agriculture. The average damage caused by the pest of failed crop was about 40% of the total crop damage. Like the picture, like the bugs will eat our things. And kind of bug, the Spototera lutena, is an obnoxious that work well. And like the economical plants and flowers, fruit trees, and vegetables will be attacked by this bug. So we find some way to know how much they are. So this research is going to put many stations in place in Taiwan, and this station will have some sensors, like the soil moisture and the weather station, and you can know the temperature, and they'll have the GPS, and most important, they will have they can counting the bug in that place, and the energy is the solar panels, and they have a battery. And the most important tool, the communication with the center, is by the GSM. And what is the GSM? That is describable protocols for a second generation digital cellular network used by mobile phones. Just like you use the cell phone and you can send a message. So this research the station get the sensors information, and it will send back to the center by the message. And this and this is the way that the system count the bug. At the left side, if we just use one sensor and we don't know that if that box is go inside to the box or go out from the box, so we use two sensors. By the left side, the bug will touch the sensor one first and touch the sensor two second. So we will know that it is going to the box. And if the bug go inside and go outside by the right side, then the system won't count this count. Yes. Okay, and this is the result. After the sensors get the message, after the sensor censoring the information, and the system might have the 8-second delay that the center can get the message. So this is very quick. Yeah. Okay. And this is the successful data receiving rate of the proposed monitoring system. And as you can see, the right side that is the is the person that receive is okay. And you can see these three numbers is very low because of the two reasons. And in these 3 months, the sun is that is the rainy day, so the sun is very less. So the solar system can't get energy. So we have no energy, so can't receive the data back. And in that season, there are 4 typhoons. So it is difficult for us to send back the message. Okay, and this is the linear regression analysis of the past counting. This is the system counting, and this is counting by the people. So we can see the people counting and the system counting is they have the R squares is very close. So that system can help people counting. Okay, and this is the summary. The study have developed a real-time automatic monitoring system for Spodopteran lutein. And the second one, the system consumes less power and equipped with solar panels achieve the goal of long-term monitoring. The third one, the system can effectively reduce the resource required by traditional monitoring method and improve the efficiency of existing pest control schemes. Okay, and this is my presentation. Thank you.
Any questions or comments? Yes, please. And page 10. You are mentioning about this is the comparison of the number count by people and the system.
Yes.
How do the people to count the insect?
Okay. After this system come out, they use the people to count the bug, and they put the bugs that can scratch the bug 10 days loop, and go there and see how many, and go back, and 10 days after they see again, like this. Yeah, and now we can use the machine system to automatically do that. Okay.
Is that okay with Peter?
Yes, thank you.
Yes, please.
Thank you for your presentation. And I have 2 questions. The first one is, how do you, in this paper, we use the number recorded by the sensor to predict the whole insect damage over the field. Is that correct?
What?
Because the sensor is separated on the field, so we use the number predicted by the sensor to predict the whole field.
Yes.
Yes. Okay. And the second question is, how do we know that something passed through the sensor that is actually what we want to measure? Yeah.
If there are another bug and we don't know like this.
So we will count.
There are bugs, and inside is the chemical things that were just let the bug inside. That bug inside is the hormone. The unique hormone, and that bug will come inside. Yes. So,
Thank you.
Any more questions? Please.
According to the previous question, if you use the hormone as keep the box into the sensors, but the machine is not distribution evenly in the field. So is this counting can prove enough because the counting machine and the field?
Is it good enough? Maybe we can see the last this that it is very it is near with people counting.
My question is because you only count the machine, but the machine is not distribute evenly in the field. So only one corner or a little space you put this machine, or you put several spots.
Several spots in Taiwan. In this, they will put many spots in Taiwan in future. But now in this research, they just put for research.
Yeah, because sometimes the machine with the hormone will increase the number of the box because attract the box into the sensor. But in other area of the field, there are no this kind of sensor, the hormone sensor. So at the hormone machine, so maybe another spot is the box won't go there without the hormone attraction.
Maybe they will try that. Really well let the body.
I could put some comment for this work. Basically, the design of the system is not to kill or to catch the insects. This work is trying to monitor the population of insects to predict is there any kind of like a storm of the insect will come up to this area. So what they're trying to do, just as mentioned, use hormone in the box and attract the male insect into the box. Although the system you see there kill the insect, which is count. What do we want to count? How many of them? Check. So this another study is the calculation of the population by either the behavior of the insects or sometimes just mentioned by Dr. Liu that, for example, in this, I think you put this in a Wenshan T station, right?
Yes.
It's Bengal T station. And so only two stations like that, and may not be enough. But this for trial. And so currently, I know they already set up probably more than 30 stations around in Taiwan. And so gradually they will set up more stations like this to give the data, from different parts of the Taiwan. And so this is the major objective of the study. So try to develop a prediction model of the insects. Okay. So any more comments? Okay, any questions or comments from Japan?
Thank you for your presentation. Actually, my question is, if one paste or fly use only the sensor one during entry and exit, it will be possible to count what will be the number of counting bits.
Okay. We can know this spot is go inside or go outside by just like this picture, where the two sensors can know. Yes. If they'll go outside and they will this sensor will first and this sensor will second find that. So I think it can know that if this spot is going inside or it didn't go inside.
Okay, thank you.
Any more questions?
Another question.
Sorry, can you open the slide number 9?
Okay. This one?
Yes. Okay, so for this one, the problem, I mean the one with the red box, you say that the problem is not enough solar energy and the Kai-Jhong decisions chances are broken, those. For the do you have any problem with using the GSM network for sending the data from the field to your main server? I want to know what is the problem, why the counting is going down. Because the counting is going down, I'm thinking that maybe the reason why is that because when the system trying to send the data to the main server, because of there's no some kind of like a buffer inside the system. The system doesn't have a local counting data. So the system count 1, an example, and it store the data inside the local buffer, or it straight away send the data to the GSM. So, that's my question. Do you get it?
Okay. This system is trying to use the low energy to do what they are doing, and the most can't send back the message. The reason is the energy is not enough. So the raining or the typhoon will let the energy enough, and they can then send back the message.
The question is the problem with GSM. Is there any problem with the GSM system?
No. Any problem?
GSM. The system used by mobile phone cell phone.
Yes.
Is there any problem? You say not enough solar energy or typhoon cause the problem, but could be possible that the problem is caused by GSM malfunction?
They mentioned that they have tried that if GSM send message is good or bad, then it is almost 100% to receive the message back if the energy is enough. So the GSM might be no problem. Yeah. Yes.
Okay, thank you.
Any more questions or comments from Japan?
Okay, nothing from Kyoto University. Thank you very much.
Okay, in that case, let's give the Kai-Jhong a big hand and thanks for his speech.
Thank you.